In this unit, we will investigate the unit fractions approach to understanding fractions, which helps us establish the meaning of fractions and how we represent fractions on a number line. In particular, we will look at the meaning of unit fractions, building fractions from unit fractions, and comparing unit fractions. An important theme is different ways in which we will represent fractions. In grades 1 and 2, students study fractions informally by describing partitions of circles and rectangles using the terms halves, thirds, and fourths, although they do not need to formally connect these ideas to symbolic notation for fractions. In 3rd grade, students start their study of fractions with unit fractions, that is, with fractions with a numerator of 1. A unit fraction is represented by one part of a whole that has been partitioned into equal-sized parts. For example, to represent 1/4, we start with a whole, partition it into 4 equal-sized parts, and select one of those parts. This understanding of fractions can also be used to locate unit fractions on a number line. We start with a number line that shows 0 and 1. Then we partition the interval between 0 and 1 into 4 intervals of equal length. Then 1/4 is partitioned by the point that is a distance of 1/4 from 0. Starting with unit fractions allows students to understand fractions by building on what they know about whole numbers. Just as we think of whole numbers as being built from the number 1, we can think of any fraction as being built from unit fractions. For example, in the same way we think of 3 as 3 ones, we can think of 3/4 as 3 fourths. Note that in 3rd grade, students understand fractions as being built from copies of unit fractions, and in 4th grade they explicitly connect this to fraction addition. On the number line, we use the interval from 0 to 1 to mark off whole numbers. For example, 3 is a distance of 3 ones from 0. And we use the interval from 0 to a unit fraction to mark off fractions. For example, 3/4 is a distance of 3 fourths from 0. Similarly, 7/4 is a distance of 7 fourths from 0. And 9/3 is a distance of 9 thirds from 0. In 3rd grade, students use the meaning of unit fractions to compare them, which is an important part of developing fraction number sense. For example, they might argue that 1/6 is greater than 1/10 because one piece of a whole divided into 6 equal-sized pieces is larger than one piece of the same whole divided into 10 equal-sized pieces. There are 3 important issues to attend to when comparing unit fractions. First, we must make sure that the fractions we are comparing refer to the same whole. We implicitly assume this when comparing fractions, but often students need this to be made explicit. For example, 1/3 of the first rectangle is smaller than 1/4 of the second rectangle, but we can't conclude that 1/3 is less than 1/4 because the fractions do not refer to 1/3 and 1/4 of the same whole. Second, students often incorrectly compare unit fractions by comparing the denominators without thinking about their meaning. For example, they might argue that 1/3 is greater than 1/2 because 3 is greater than 2. To see why this reasoning doesn't work, sometimes it helps to consider a context, such as sharing a toy. If Ben and Kristen share a toy for an hour, each one gets to play with it longer than if Ben, Kristen, and Linda share a toy for an hour, assuming they all get an equal amount of time. So in the first situation, Ben and Kristen each get 1/2 hour of playtime, while in the second situation, Ben, Kristen, and Linda each get 1/3 hour of playtime. Finally, when a fraction is represented by area, there is an additional level of complexity because different shapes can have the same area. Students first see this in grade 2, but they tackle it more directly in grade 3 when they study area directly. We see some examples here of shaded regions with the same area of 1/2, yet the shaded regions are not necessarily congruent to each other. One final note It is possible to represent fractions with geometric figures based on length, or area, as well as sets. However, students only use connected wholes in 3rd grade. A good time for students to work with fractions of sets is when they are studying fraction multiplication in 5th grade. Then they will be able to connect a statement like 1/2 of 4 with the product of 1/2 and 4. The added complexity of representing fractions with sets suggests they should be postponed at least until 4th grade.